Today we're going to learn about pinpointing a leak. And then we're going to cut and cap it after. Okay, this is just a, example how to pinpoint a leak. So we got to either have coil 1, 2, 3 little sections, right? See the coil back there. So one of our questions is the coil leaking, or is over there leaking, or is multiple spots leaking? So what do we just do? Just take our little thing, put it right there. Why? Because that's sucking air in, blowing it through, coming out the coil. If there's a leak, we'll sense it. And then right there. And then right there. There's more over here. So if there is a leak on the coil, it's probably on this side of the coil. And we're also going to head over here. Always check the piping too. Because it could really be anywhere in the case. TXV. Right? And down here. We're getting pretty good amounts there. But we can't just believe that it's that. We have to see if maybe it's just the whole area. So we're going to have to clean this up and remove some things. See if we can find anything. So what I did was I turned up the sensitivity. We'll turn down the sensitivity. So now it's, if you look at that, it doesn't even register the calibration reference anymore. So if you want to know how to calibrate it, I think I got a video on it. Anyway, so we're going to come in here and then we're going to look. We're going to see. So I put that in there. There we go. You can see that there's something in there, but if I come around here where I was before, there must be just some type of wind current that is carrying it outward, because I sprayed the whole area with soapy bubbles. I got my soapy bubbles right here, sprayed every joint. I sprayed the fitting itself, TXV, the screen, the power head, right? Spraying all around next to that sensing bulb. See if maybe that's leaking, right? Nothing seems to be leaking in this area. You don't see any bubbles, any formations. So there's something in there, so I'm gonna have to take this apart further. So we can see now that it's open more, you can see that it's not actually, it doesn't look like it's actually this pipe that's leaking. We're still gonna check it with our soapy bubbles. But if we go over here, we can see it looks like it's this meeting of the coil with these loop passes right there. So, right? So we're going to take some soapy bubbles and we're going to take a look at it. Even right there, that looks a little bubbly, but that just could be just because, oh, there's another one down there. So you see if those loop passes are leaking. So we'll take a look and see if it's repairable or if they even want me to attempt to repair because it's so rusty. So you can see on those loop passes, we got some bubbles coming out. So we got 1, 2, 3 loop passes that are actually leaking right on the sides of them. You can see I took it apart further. As we found in the beginning, both sides, both loop pass sides are leaking. So I'm actually thinking I'm going to just cut and cap this coil because I would physically have to remove the coil out of the case to repair it. And at that point, we might as well just replace it. So I spoke with my boss. So there's 4 leaks over there, 3 leaks over there. It's not worth repairing. I agree. We're just going to cut and cap it over there. So we're going to look for A23, cut and cap. Okay, so really quick, got my gauges hooked up. So we got the high hooked up to the liquid, the blue hooked up to the suction. We only closed off the liquid. So now all of that liquid's flowing through the circuit and going back to the header. We also have it hooked up and this chamber opened up to over here where we have a negative 28 header, which is lower pressure than a positive 13 header. So now what I'm gonna do is I'm gonna, now that this is down to the rack pressure, I'm gonna come over here, gonna turn off this suction, just like so. So now this is all suctioned down. So now the only way out of this circuit is through this line, all the way over to this liquid header over here. So we're gonna start pulling down the pressure in that evaporator coil to be on the same as the low temp, and I'm gonna go get my recovery machine while it's doing that. Okay, so this is all up there right now. So this is at 0, just like I said. So now what I'm gonna do is I hooked it up to the vacuum pump. So I'm gonna unplug my recovery machine. That's using the yellow one, so the yellow one's closed. Okay, gonna open up the blue one, open up the red one, and I'm just gonna
you know, this is my personal preference. You don't have to do this at all. A lot of people will just go right down there and braze it up. I like to just draw a small little vacuum. Nothing crazy, not like a, you know, not 500 microns, just a little vacuum. And I like to do that just enough to make sure that any liquid refrigerant that's in there, not liquid, any refrigerant that's in there is vacated out of it, because I just don't like phosgene gas. I don't like it. It burns my lungs. It makes me cough for a couple days. It stinks. Get the refrigerant out of there. Okay, so now we have the recovery machine. So this is marked off. That's closed off. So the liquid's closed off. The suction closed off. There's no hot gas on this. If it was a hot gas line, all you'd have to do is close off the hot gas too. There would just be a ball valve for that over there. Anyway, so we have both of those going into my gauges. We have the blue open, the red open, and now the yellow open, which goes down into the in and not out, and in over there to the suction side of this, just this frozen fish freezer right there. I was going to plug it in up here, but it's so rusted, I don't want to risk snapping something off. A couple of my more adjustables are in my bag, and it's down to a bunch of ladders and stuff. But anyway, so what I'm going to do is I'm just going to wait for this to get down to 0. I do not want to put this in a vacuum, and when it gets down to 0, I'm actually going to draw a vacuum with my vacuum pump, because I want to evacuate any refrigerant that's in there, because I don't want to braze with phosgene. It's just not good. Gets in your lungs, causes issues, not pleasant. But I don't want to pull this into a vacuum with the recovery machine, because I don't want to recover moisture and air into the system, because there's holes in that evap coil. So if that's in a vacuum, it's going to be sucking in moisture from the outside, and it's going to put it over here. So when I get to around 0, I'm going to turn it off, you know, kind of look at it, because like right now, you see how it's like 0? Well, if I do this, it's actually going to spike back up. You see, spikes back up to 14, 13. So it's going to take a little bit of, you know, twisting back and forth. When I get that down to 1 PSI, 0 PSI in the line set after I close it, that's when I'm going to turn it off. Literally just like that. You see, just hardly a vacuum. -2 on one side. I think that'll be good. Just had it running for like a minute, you know, good to go. And now you can see it's even, you know, kind of building back up, because yeah, you know, there's the holes that's exposed to the outside world, so, you know, the holes in the coil, so eventually that vacuum will even go away. So anyway, I'm gonna go down there and we're gonna cut and cap it now. Okay, really quick, I just want to interject this so I make sure that people understand what I'm doing, right? So this is a really basic system. So, you know, we have our, you know, compressors, 1, 2, 3, 4, right? The discharge line comes out, goes to a condenser, turns it down to a liquid. You got a liquid line right there, right? Out of that liquid line, we have this liquid line that goes down and feeds our 4 cases in the circuit, which is, you know, circuit 23A, 23, it's very hard to draw on a camera, 23B, you know, so on and so forth, all the way to 23D, which we're going to say is this one over here, 23D. Okay, that's the one that we're actually working on, right? So what I did was I closed off the liquid, the liquid line, the liquid side, right? And I plugged it into my testos, right? I then opened my testos and I let all that liquid and suction pressure come down. So all this liquid, now this is closed off, right? So this liquid has no choice but to flow through high pressure, right? Liquid's 180 psi. Suction is low pressure, which in this case is 49 psi for a plus 13 degree coil. Okay, so this high pressure flows to the low, okay, causing this whole circuit to pull down to that 49 psi. From there, I then closed off the suction side, opened up my gauges, and had them flow, you know, out of the liquid line, out of the suction line, right, to the header that was next to it, which is 13 psi. So this lowers it further from 49 down to 13. Then from there, I take my recovery machine, we're just going to put my recovery machine right there, and we're going to hook one side into one side of the recovery machine and the other side into the other side of the recovery machine. And now this will suck out the rest of the refrigerant recovery. I'll just put recovery machine. And now that sucks out the rest of the refrigerant and pushes it into there. Now from there, after we braze up everything, we're gonna go down and we're gonna, just after the TXV, right here's the evap coil, we're gonna cut it right there. And then we're gonna cut it on the suction side of the evap coil. And then we're gonna braze those. So now you can see that when we open up this system, refrigerant's going to go everywhere, except it's going to stop. Sorry about that, my phone died. So anyway, as I was saying, so, you know, we're going to go down, we're going to braze on one side just after the TXV, and then after everything on the other side of the coil, we'll braze there, right? And then from there, we'll set up our vacuum pump, right, which I'm just going to hook up to the vacuum line over here, and just vacuum pump VP, right? And I'm going to close off this one to the recovery machine, and now we're going to pull a vacuum on those two lines, right? And now all that's going to be left is now this evap coil is just going to be gone, and those are just going to be plugged, right? So high pressure still goes to low pressure, so the rest of the system will still work just fine, because all the rest of the system is a large pipe that comes out, and you have these little branches that come off. The large suction line comes out, these little branches that come off. Okay, so those three other evap coils will not be affected by this. Now, one more thing is, if you are cleaning a TXV screen, it's the same exact thing, except of course you don't cut and cap, but you just pull a vacuum again, open up the system, and you're good to go. Anyway, I hope that clears it up. Back to your regularly scheduled video. There we go. So not that it matters, but I'm just showing you. I have a cheapo set of gauges that I use to make sure that actually at the system there's no refrigerant in it. This would be a pretty decent place to interject this, but you know, this is also a way I can verify that the liquid lines has nothing in it, as it would be dumping out right now if it did. So, you know, this is just how to clean the TXV screen. You know, just pop it in the video, why not? So you can see that screen's pretty, I would say that's fairly plugged. Look at that, that's pretty dirty. Good way to know is you hold it up to the light. If you can't see light through it, it's clogged. So it's kind of hard to see. I'll try to zoom in with my camera. Maybe you can, there you go, look at that. See how there's a fine powder in there? Yeah, that's not good. So you want it to be see-through, so you can roll it in your fingers, just like that. Okay, now that the system's pumped down, we can do this, and then you can tap it. See all that? You start to see it a little better. Roll it in your fingers, tap it. Okay, that's better. Yeah, I got degreases solvent, removes oil and gas. This is NU Calodon. Somebody asked one. Anyway, that's just the one I get from Web. We're just going to spray it inside the case. There we go. Look at that. Much better. Put it back in. Good to go. Okay, so really quick to show you. Got a little pressure tap there. Took out the straighter core. Okay. I cut them both. You know, cut them liquid line, suction line. Okay. Just a pair of pipe cutters. Milwaukee pipe cutters. Okay. Just cut them. The reason I cut them there is it's just going to be convenient. So they're easy to take the coil out, put it back in, easy to put back together. That's really it, just an easy spot. I would have rather cut it on the other side of the pressure tap, but it was harder to cut there, so cut it there. So all you got to do is, you can see that this is the first state that it starts in. It's rounded. So you heat it up a bunch, and then you pinch it. So you got to heat it up a ton, and then you just pinch it. And if it's possible, you can get it to have that nice little lip right there. And then you just fill that lip with braze, just like I did over there. And I did right there. Now you might say to yourself, why am I filling up this size with this stuff? Because I want to keep that side as isolated from moisture as I can, because we're still going to reuse the distributor lines. So right now I'm going to come over to my little bag over here, my little thing, and I'm going to get my mirror, and I want to check, make sure that the bottom of that is done. So you can see that one unfortunately pinched the other way, and there's still a little hole. That's why I try to pinch it this way if possible, so I'm going to have to fill in that little hole. I also have a little piece of sheet metal right there and a bunch of rags to protect the case. So you see, nice and red just like that. Now I'm going to pinch it using a 15 tip. I'm going to pinch it.
I'm just gonna wait for it to cool for a minute, and then I'm going to check it with my mirror. Good to go. Not good. See the little hole? Gotta keep going. Good to go. So just to let you know, I got a metal wrench that I use to prop everything up, just as people care. Bucket of hot water, oxygen, acetylene rig, and how I'm set with these very precision gauges. You know, these that I have on there. They're super precision, as you can tell. So anyway, that's what I'm working with. Should be all set now, so I'll put back the straight core, and we're gonna go pull a vacuum.
So you can see we're getting a little bit of alarms here. That's not good, right? Those are all the other service delis that's on that circuit, so the 3 cases next to it. So when we're done with everything, we're gonna have to override the value of the case that we just did. But that's part of the reason we're cutting and capping, and we're not just closing it off, because now we only have to close off 1 case versus closing off, you know, 3 full lines of product. All we gotta do is close off this one, you know, product right here. Right now, what are we doing is we have these 2 connected to the gauges. This one's closed right there, so blue's open, red's open, vacuum's open, all the way through the vacuum pump, pulling the vacuum on the whole system. So we're going to wait till it gets to 500 microns, 29-inch vacuum, and then we're going to crack it with suction pressure if the vacuum holds, and we're going to take a look and make sure that those caps hold for suction pressure. Now, some people, like I've seen people check with nitrogen, and I've seen some people not. I just definitely won't with this store. This store is way too old. I don't want to contaminate the system. So checking at suction pressure is completely fine, especially if the vacuum holds. Also worth mentioning, we got to order a coil, but that case doesn't have any case information. This is inside the rack. Somebody actually mentioned this in the comments, so thanks for mentioning that. It's actually helping me today, so we can see the model of that case right there, and it'll even give you, you know, suction size, you know, the valve. Sometimes it gives you the BTUs as well. So 500 micron vacuum, been holding for a while with 30 inches of water column. We're gonna come over here, we're just gonna crack this suction side just a little bit, and we're just gonna release, you know, maybe like 10 pounds of refrigerant into the system, something like that, 20 pounds, something like that, and then we're gonna go and we're just gonna go and check and see if it's leaking. That'll be just fine. So that's closed now. So now I'm just gonna, actually both sides are 30, good to go. So I'm gonna go downstairs, spray with soapy bubbles, and we'll check it out. Also, some people mentioned that they wanted to know what I was using. So this is the original Big Blue Micro Leak Detector Ultra Sensitive Formula Long Lasting Bubbles right here. So the reason I'm using this is because if you use actual like Dawn dish soap, it'll erode your pipes and then you have leaks, and it's not good. So buy the actual stuff so it doesn't erode your pipes, especially if you're going to work on equipment that'll be there for 20 years. So that's not doing nothing. So make sure, feel around it, not doing nothing. Gonna turn it up all the way now. So now we're just gonna open these both up. I'm fairly confident it looks good. Held the vacuum, past the soapy bubbles. So now we're just gonna open up the suction side first, just to break that pressure with it all the way. And now we're gonna open up the liquid side over here. And then we're just gonna soap check, leak check with the leaky bubbles again, and that's just it.
So you can see, holding, all good to go.
Okay, so now that what we're gonna do, so now we're gonna look at our controller and we're gonna be like, oh, okay, let's look at the A23 and see how it's running. So we're gonna look, all the A23s are at temp, but A23D, realistically, it's really not at temp. But what I did, and what you're gonna need to do, is you gotta go into service and then go down, and then you're gonna keep going till you find all the temperature probes right there, A23D service deli manual. And I'm gonna put this for, I actually don't know why, but it was already on the manual. I'm gonna put this for 33. Actually, no, I'm gonna put this for 33. Why am I doing 34? 34. Doing 34. Why am I doing that? Because in all of those cases are run off of it, right? So we're going to have 23, 23B, 23C, 23D. All those cases are run off of it. And the way that this controller works is it takes an average of those cases. When that average is over the set point, which the set point would be 33, right? When the average is over that by the range 2 degrees, then that means it will energize this suction EPR valve, turn it on, causing the flow of refrigerant, causing those cases to pull down. So if I have that case set to an artificially low number, it's going to read that it's already satisfied sooner, even if the other case is on exactly the best temperature or an optimal temperature. So anyway, so that's why we got to put that in. Also, if we don't put that in, you're going to have the Danfoss monitoring company call you over and over and over and over again and being like, hey, your case is running warm, and then you're going to get called back, and then the on-call guy is going to get, unnecessary work. That's what we're going to say. He's going to have an unnecessary thing he has to go to on call. We'll call it that. Anyway, so we what do we do? So we found the leak. We determined that it was irreparable, and we cut out the coil. And then after we cut out the coil, we leak checked, made sure that it's not leaking out of our caps. And now we turned back on the whole system, made sure everything else pulled temperature, and put that offset into the temperature probe. Anyway, so hopefully you learned something today. Hopefully that helped you. This was a recommended video. Also, if you stayed all the way, I really appreciate it. I really hope you learned something. I'm gonna go get some Chinese food, and that's how you do it.